I'll switch over here in just a second and start projecting. So, does anybody have any questions about Chapter 7? They want to talk about the isometric drawings. All right. So, several of you wrote on those, when you name those, you put 3D in the name of the file. And actually, those are not 3D drawings. They look 3D, but they're isometric drawings. They are 2D drawings. So just keep that in mind. We'll get into 3D in a couple of weeks. So I'm going to go ahead and present my screen to you guys. That's the plan anyway. And so I'm going to click over here, pick share, and let's see what happens. All right, so you may want to set your screen to maximum size there. So are you seeing what it looks like is a PowerPoint? It says section views. Good. All right, so let me expand on that then. So today what we're going to be taking up is section views and what those are, and we'll make some drawings using section views. So let me just skip through this and show you. Here's an example of a section view right here. So we have a front view and we have a top view, and in the top view we see we see 5 holes, and they're all different types of holes. But what we're used to seeing would be a center line running across right through here, but instead we're seeing this heavy dashed line that has a couple of vertical lines on the end, and then it also has, let me get another, change the color here on this guy. Oh, come on. Anyway, it has some arrowheads on the end. And so here's the arrowhead right here, and the arrowhead's pointing up. And so what that tells us is that in this view down here, that this is a section view, okay? And that means that the part has been cut in half, and we're able to see what's going on inside the interior of the part, all right? So it's been cut along this line right here. So it's been cut like that. So imagine if you could take a hacksaw and cut down through the middle of this thing. And then what you do is you imagine that this half here has been removed, and you were standing here and you were looking in this direction at the top view after it's been cut in half. And so you have to use your imagination and think about, well, what would that look like? And then that's what you're going to draw right here. Okay, so we are standing below this part. We're looking straight up. Our cutting plane line runs through there. We're looking in the direction of the arrowheads, but we're always behind the cutting plane line, which is this guy here. So we see this spot-faced hole and a hole that's drilled to a depth, and then a hole that's drilled all the way through. We have what's called a counterbore hole and a countersunk hole. Now, in here, those diagonal lines, those are called section lines, and we place those using a command in AutoCAD, which we've already used, called the hatch command. All right. So the reason why you would do a section view in the real world is this. You've got a part and it has a lot of interior detail, and you need to be able to dimension that detail. So, what you do as a drafter, you think about, okay, I could just show the front, top, and the side view of that part with all those hidden lines, and I can't dimension the hidden lines. Or you could say, what I ought to do is cut this thing in half. I should do a section view with one of my views, and that way those hidden lines become visible lines, and then I can dimension directly to the visible line. So that's where you make that decision. And so remember that engineers don't know a lot about technical drawing. It's not in their training anymore. So when an engineer hands you a sketch or gives you an input and wants you to draw it, the engineer probably will not say you should section that. They don't know enough to tell you should section that. This is the decision that you have to make as a designer or a drafter, So this is one of those decisions you make that is a part of doing your job. So I'm going to skip and I'm going to show you a couple of other examples of this. So in architectural drawings, sections are really common in architectural drawings. This is a sketch of a foundation section. So this would be on the side of a foundation. And so if you look right there, I think I pointed this out to the class the other day, that when you see a rectangle like that and then it has an X across it, that you're probably looking at the end view of a piece of lumber. And in this case, this is the bottom plate of a wall, of a stud wall. So the stud wall is going straight up here. This is the bottom plate. And so what this section is showing us here is that there's an anchor bolt that is this bolt that's threaded on the top, and that is pushed into the concrete while it's still wet. And then when we tilt up that wall, we've drilled a hole in the bottom plate, and we can actually attach that wall to this bolt that is set in the concrete right here. And then inside here, we can see a hatch pattern, which is actually for concrete. And so it has some dots like this, and then it has some things that would represent maybe some rock or something like that, some aggregate. And so this is actually a hatch pattern. It's called Conc, C-O-N-C, for architectural concrete. So if you take the architecture classes next semester, you may get into using some of that right there. Right here, you see this these lines that are run at, they go diagonally and then they kind of come at the opposite angle right there. What that represents is the ground line or the grade. So we've got earth packed up underneath the foundation, and then we have the actual grade of the yard is right there. Like the top of the dirt would be right there at the top of that line. But this symbol that we have right here, there's even a hatch pattern for that. So there are, dozens of hatch patterns that AutoCAD gives to you to use, and you can even create custom hatch patterns if you want to. So here's another architectural section view. This is a wall section, and so the thing about this wall, you see the structural parts, but you also see the insulation, and you see that insulation batting that's between the studs, right? And so the thing about that, there's a hatch pattern that looks like that honeycomb shape. And here's that hatch pattern for the ground, and here's the Conc hatch pattern. I don't know if there's anything for this brick right here. That may have just been, drawn one brick and then used the array command to put those guys in there. But here's a hatch pattern filled in up here for insulation. So if you want to know about how important are section views, every time you go to get a building permit, the city of Austin is going to require some wall section views because they want to confirm how much insulation you're putting into the walls, and they want to see the foundation, and they want to see all that kind of stuff. So usually sections are a required part of a set of plans when you go to the city. So to kind of make the point, imagine that you have an apple and you slice the apple in half. And I want to point out here, we're using the A&E CAD pocket knife to do this, so we've spared no expense here at ACC in your training. So imagine that you've cut through that. You've removed this half right here. And then you draw what you would see. So here's your full section of the apple after it's been cut in half. So if you had a cutting plane line on that, the arrows would point in this direction, and you are standing here and you are looking in this direction right there at what you're going to see, and that's what you would draw here. Okay, and so I'll show you that when we see it on a machine part. So imagine that this is your front view and this is your right side view. Well, normally all these lines here would be hidden lines, right? But because we've added a cutting plane line in here, which is, we're going to draw that as a heavy line. We'll probably set that to like 0.05, actually 0.5 millimeters, 0.5 millimeters, half a millimeter in thickness, because we want that to stand out. So we run that down through the center of our view, and then when we draw our right side view, instead of drawing it with hidden lines, we draw it with visible lines. Now, when you draw things with visible lines, it's okay to come over here and put dimensions on there. Like if you want to say what that diameter is right there, you can put it in the side view. ASME allows you to place those into the side view. And you can put dimensions, for example, the centers the dimension between the center of those holes right there can be placed on this view once those are not hidden holes anymore. All right. So this is an example of what we would call a half section. So in the half section, your arrowhead points up like this. There's not an arrowhead over here, no arrowhead over there. You're just looking straight up. You're removing a quarter of your part, and what it results in is what we call a half section view. So what's kind of confusing about this is that we remove 1/4 of our part to get a half view. If I back up to here, we remove half of our part to get a full section. So this is called a full section over here, but this half of the part is gone in that. All right. So it's surprising how many times in industry I come across people that are drawing their sections incorrectly or notating their sections incorrectly. One time I was on a consulting job at one of the national laboratories, and these are the guys that design nuclear weapons for the United States, and almost every section view that I looked at was drawn incorrectly. And so I had to subtly point that out to them that, you know, they needed to relabel and rechange the arrowhead directions and all kinds of stuff like that. So it happens out there in industry. People get it wrong. So what we have here is what's called a half section. So here's our machine part, and the cutting plane line comes up and across, and then here's our arrowhead. So that means we're removing this portion right here. We're looking in the direction of the arrowhead. The top of our head would be about right here, and we're looking straight up. We draw what we would see. So from this center line to the right, that's a section view. From the center line to the left, it's not sectioned. All right. So, you know, you could add your hidden lines in here if you wanted to, but here's the thing. According to the ASME convention, if you do a half section like this and you section part of your view, they don't require that you put the hidden lines in this view over here. You can if you want to, but they don't require it. All right. Now, for us, that would actually be pretty easy. If you drew this, because we use AutoCAD, we could mirror all of these lines over to this view over here and then just put those on the hidden layer, and it would take us like 20 seconds to draw those over there if we want to include them. Okay, so there's a half section. The line that separates the two views from the section view to the non-section view is a center line. All right, so you can orient your parts differently. It's still a half section, so we're notching out right here. We're looking in that direction. With this part's gone, you're standing right here. Here's your nose. You're looking in that direction right there, and you draw what you would see in here. Okay. So I know I'm kind of repeating this over and over, but it's important that you get this concept down. Now, sometimes you're going to have what's just called a broken out section, and that's when you don't need you don't need to spend all day doing a section. You can just do this right here. So this is like a partial section. And all I'm trying to do in this drawing is show this small hole that's on one side there. And because I'm sectioning it, I could actually come out over here and put dimensions to like locate where the center of that hole is. You could even point to it and say what its diameter is. All of that would be allowed because we're seeing it as visible lines now. So if you look in the ASME standard, you'll see all these examples here. Okay, so look at this irregularly shaped line that we have right here. When you draw that line, probably what I would do in AutoCAD is use the command called Polyline. And it's on your draw toolbar. We haven't used it much, but the Polyline is a good line or a good tool for drawing a line that's kind of irregular like that, because all the parts of the line are connected to each other, so that behaves like one entity. And the alias for Polyline is P-line. If you just type P-line and press enter, it'll put you in the Polyline command. And so you can see how irregular that line is. Students say, how do you know how to draw those? Well, it's just art. You decide where they go, okay? Now, here's the cool thing about this. If you do a broken out section out there in industry, and then some mechanical engineer walks in and sees your drawing with a broken out section, they will probably think you're a genius. Okay? Because they're going to look at that and they're going to go, oh my gosh, look at this. This guy really knows what he's doing, or she knows what she's doing here, right? Because look at that. Look at that irregular shaped line and the whole deal. So anyway, just keep that in mind, that you can impress your boss by doing things like broken out sections, because they think you're some kind of artist genius, something or other. And of course, never let on that you're not. All right, sometimes you'll have a part like this guy up here, where in the side view it looks like this. It looks rectangular, but just by drawing this circle right here and putting a hatch pattern in it and putting a dimension on it, you can indicate that this part is actually round. And so that this end down here is round without drawing an end view. You know, normally you would think you would have an end view over here of all that stuff, and then you'd try to dimension it. But you can do it like this if you're, and still follow the ASME standard. So here's another example of what we call a revolved section right here. So this is actually a hex-shaped piece right here, if you look at it from this end down here. But so you just rotate it right on the part, you add a hatch pattern in there, and you rotate this and add a hatch pattern. Okay. Sometimes you're going to have a part where you draw a cutting plane line, and you'll label it like A and B and so on, and then you'll actually remove this and draw what you would see if you were looking in the direction of the cutting plane line right there. And you'll draw it somewhere else. So you'll draw a circle and you put your center marks on here, and you'll label that as section AA. And so that's what you're going to see right here. Here is section AA, which would be what you would see looking in that direction. And here is section BB, which is what you would see looking in that direction. And these removed sections are really common in architectural drawings, where you may have an entire sheet of section views that are labeled. And then you have to go to another sheet where you'll see all these cutting plane lines and what all the labels are, and then you'll relate those to a different sheet to find section BB or section AA, so on like that. Now, one thing I want to point out to you, whenever you're labeling things like AA, BB, CC, and so on like that, you're okay until you get up to like I. The standard doesn't like you to label something section II because it looks like two ones, and it's confusing. Same way with if you try to have section 00, it looks too much like section 00. So they generally remove some things and don't let you use those. If you get into a drawing where you have more than like 24 sections, so you run out of letters of the alphabet, you get up through ZZ, what you do is you start over and you start labeling things AA-AA. And then you just keep on going. So BB-BB and so on like that. So you didn't know when you paid for this class you were going to get all the insight on what's going on out there in the real world, did you? All right, so sometimes you're going to have a part where features don't lie in a straight line. So you can't just put one cutting plane line through like this and catch everything. So it's okay to draw a cutting plane line that looks like this one, where it comes across and then it jogs down and it goes through these features here. It could have even jogged up and come through that feature and then come back like that. And then you would draw what you would see down here. So this is called an offset section. And something I want to point out about that is this, that if you had a hacksaw and you cut through right there, and then you made that vertical cut right there with your hacksaw, and then you cut the rest of the way through, and you removed this half right here, you would expect to see an edge right here in that view, but the convention is to not draw that edge. So it looks like it's flat all the way across, but it's actually not. So they teach machinists that when in blueprint reading classes, that when you see an offset section, you should not expect to see an edge right there. Okay. All right. So the way you put the hatch pattern in is using the hatch command, or the way you put the cross hatch or the section lines in is using the hatch command. And remember that when you pick on the hatch command, your ribbon changes, and your ribbon is contextual, and it will start to look like this. It will just be related to the hatch command. And so it's in the swatch area that you've got these down arrows, and you can pick on that, and you can pick arc concrete, or you can pick the insulation or anything that you want. What I've been using in these drawings we have so far is called ANSI 31, ANSI, American National Standards Institute 31. All right. Now, that's actually kind of a misnomer. This is old. ASME has supplanted ANSI in making up these rules, but AutoCAD still is referring to it as ANSI 31. So it's the same thing as ASME. All right. The other thing you control in here is the angle of the hatch and the scale of the hatch. And so the scale of the hatch determines how close together the lines are going to be. And so we'll get into some of that here in a minute. So I'm going to skip through this because I'm going to show you a little bit more. So here's a good example of a hatched side view. So here's your hatch pattern in here. This would be ANSI 31. All right, that would be the swatch that's used there. The scale, like I said, determines how close that the lines are together. If your scale is too small, your lines will be too close together, and if it's too big, they're going to be too far apart. The angle, you have to watch out about the angle on your hatch pattern, and the reason for that is this. When you look at the angle of ANSI 31 right here on your ribbon, it's going to say that the angle of this is 0 degrees. Now, obviously it's at 45 degrees, but because the hatch pattern comes in like that, they call that 0 degrees. So if you put 45 in here because you think that the hatch pattern ought to run at 45, well, it's already running at 45. So if you add 45 to your angle, what it's going to do, it's going to rotate this counterclockwise 45 more degrees, and your hatch pattern is going to just be vertical lines, and then it's not going to look right. So be careful about changing the angle of your hatch pattern when you're working on that. Okay, so what I'm going to do now is show you what your first assignment is going to look like when it's done. So we're going to open up in project 8.1, we're going to open up the tool holder that you guys just drew an isometric of. If you've drawn the isometric, you may not have drawn this guy yet. A lot of you have sent this in for a grade. And by the way, I sent out a video yesterday showing you how to do these tangencies back here. When you have that ellipse coming in and on the bottom right down here and on the top, how do you get these lines to come in as tangents? So I made a video and I sent you a link yesterday in an email. So if you haven't received that, you might want to go look at that. But here's what we're going to do. We're going to reopen the tool holder, and we're going to go to the top view, and we're going to add a cutting plane line that runs all the way through it, and the arrows are going to point up, which would mean we're cutting it in half, we're looking straight up. So that's going to change this view. So you're going to edit this view right down here. And right now, this line right here is a hidden line. And the lines for the edges of this hole, those are hidden lines. And so you're going to be changing those to visible lines, because when we cut this thing in half, those are not going to be hidden anymore. You're going to see the edges of them. So you'll convert these, just put these on the hidden layer, the visible layer. They're on the hidden layer now. The other thing is this line that you have right here currently goes all the way across, so you're going to have to trim it back to right there. Then you're going to add a hatch pattern right in here. And so you're going to make a layer called hatch for this hatch pattern, what you're going to put in, and it's going to be default line thickness. And the directions tell you all this stuff, so you don't have to remember everything I'm telling you here. But anyway, that's going to be thin. That's going to be default. And then you're going to also make a layer called cutting plane. Okay, and the cutting plane layer you're going to set to 0.5 millimeters thickness. And the line type is going to be dashed X2. You've got a line type you're going to have to load. It's called dashed X, so it's like times 2. What that gives you are these long dashes that are longer than hidden lines, longer than the dashes in hidden lines. And because we're setting it to 0.5 millimeters, it's going to be a heavy line. All right, so that's your first assignment. The second assignment is project 8.2, which is this guy right here. Let me go back here. Come on. Somehow I lost my pointer. Okay, so you're going to draw the front view and the top view of this guy. And the top view is going to be a section. It's going to be a full section, and you're going to add dimensions to it. You'll add a note about what its material is and everything else, just like you did in Chapter 5, except it's going to be a section view. Now, when you count the dimensions on here, you only have like 10 dimensions. 5, 6, 7, 8. You have 8 dimensions, plus you have a material, which is shown in your book, and you also have, we're going to put a reference dimension giving the overall width of this guy. So remember, a reference dimension is going to be in parentheses, and that's going to be 10.00. The way we get that is it's 8 inches from the center of this hole to the center of this hole, and then you have a 1-inch radius here, and you have a 1-inch radius here. So you have 8 plus 1 plus 1, you get up to 10, but that needs to be a reference. It's not going to be toleranced. All right, so this is what your view would look like once it's cut in half. So your section's going to look something like that. Your dimension style, these are the settings for it, for the text height and the arrow sizes and all that stuff like you did in Chapter 5. And let's see if I have a help sheet in Blackboard that looks like this. So here's what you can imagine. If you had a 3D model of this, here's your cutting plane line. And so this half of your part is gone. And then this is what your top view would look like. This is a counter sunk hole, and these are the dimensions used to draw it. This is a counter bored hole, and these are the dimensions used to draw that. This is the note that goes with what's going on here, and this is the note that goes for what's going on here in your counter bore. Now, there are videos that cover all of this, so I think you really should watch the video. So let me get to the final. I think I've got the solution here at the end. Let's see if we can get to it. There it is. So this is what your figure 8.2 is going to look like. And when you get it drawn, you can send it to me and I'll send you a check print once you've got it dimensioned and everything. So this is our assignment between now and Thursday, is to draw 8.1 and 8.2. They really go pretty fast. And 8.1 is more of an exercise just to get the hang of things. And 8.2 is the one where you're going to get a grade on it. And so one of the things that it's going to go into is how do you get AutoCAD to write these notes right there, because you have this symbol for a countersink, and then over here on this guy you have the symbol for a counter bore. And so that's going to be covered in the videos. And it's also covered in Chapter 8. I'll kind of point out the pages where it's covered at on what you're going to write as far as your text goes. If you look on page 360, what we do is we're going to write like a lowercase v, and then we're going to convert that to the GDT font. And when we convert it to the GDT font, it's going to draw this symbol right here, which is a counter bore symbol. So we put a lowercase v in and when we put that in, it's going to be Arial, because everything that we have is Arial. And so then you're going to highlight that in the text editor, and you're going to set it to a font called GDT, which stands for Geometric Dimensioning and Tolerancing. Just that. And when you do that, it's going to replace that lowercase v with that symbol right there. If you use an uppercase v instead of a lowercase v, that's not going to work. And so you can see that on the top of page 360, and it works its way down, but it's also covered in the video. The same thing happens when you try to annotate that counter sunk hole is that you're going to write a lowercase w. So when you want this symbol here, you're going to write a lowercase w and then highlight it and convert it to GD&T, and it's going to change and become this symbol right here. Now, here's something that is stupid that AutoCAD did. They have a V that converts to a counterbore. Then they have a W that converts to a countersink. It seems to me they should have used the V to do this guy. Right? So somebody should get fired for that one. But anyway, so just keep that in mind, that you've got to keep those straight. All right, next thing I'm going to do here, though, is escape out of this, I hope, and run over here to AutoCAD real quick and jump on this right here. All right, so your view starts out looking like this right here, and you have these hidden lines in here, right, that I was telling you guys about. So when you cut this in half, and here's my cutting plane line, first thing I would do is use match properties. I would use match properties, and I would pick a visible line, and then I would pick that hidden line, and this hidden line, and this hidden line right there, and convert those to hidden lines. Then I would pick on this and drag it back. Let me pick on it. Drag it back to right there. You'll still need this little line right here. And at that point, you're pretty much ready to put a hatch pattern in there. Okay, so you would want to get onto your hatch layer, and the assignment tells you to make a hatch layer. So you get on your hatch layer, and you come over here, and this is your hatch. You pick on it, and it's going to open up the ribbon, and you want to select ANSI 31. But right here, it's saying pick points, right? And all you need to do is pick inside there and pick inside there, and you can see it adds the hatch pattern. As far as the angle goes, we're going to leave that at 0, and the scale is going to be at 1. But I want to show you, if you change your scale, let me put a scale of 2 in there. Let's see if I can get that. You see how much farther apart that the scale is at 2 than it was at 1? And if I go like 0.25, then my scale is 2. They're too close together. So sometimes you have to experiment with that. And on this one, 1 is the correct setting. Now, I wanted to show you about drawing these arrowheads, because this is something you guys have not had to deal with before, is drawing a big arrowhead like that. I'm going to show you a trick for drawing the big arrowheads. So this layer that I'm on right here is called the cutting plane layer, and so I'm going to pick on that. So the cutting plane layer, we're going to set it line type to dashed X2, and I'm going to set it to 0.5 millimeters thick. So it's going to print thick. And I want to show you something about if you, let me move this out of the way. Remember this, this switch right down here on your status bar that shows your line weight? When we click on that, you can see how thick that's going to be compared to like your visible lines and your center lines. Center lines, everything are still going to be thin. Your hatch should be thin as well, even though the visible lines around it will be thicker. Okay, so when I draw this this arrowhead right here, I actually draw that using a Polyline, and I mentioned the Polyline a minute ago. Here's the Polyline command is right over here. It's under the Draw toolbar. You can also get it right here, Polyline. And when you pick on Polyline, one of the things that it will let you do is have a width to it. So you can see mine is like crazy wide right now. That's way too wide. But you come here and you pick on the word width. And at that point, it will ask you, what is the starting width of your polyline? So if I said 0.5, for example, and I press enter, and then it says, what's your ending width? And I keep that at 0.5 and I press enter. You can see it's a lot thinner. And this is what I was talking about, how a polyline can be used to draw an irregular line, right? But I'm going to delete that guy out because I'm going to go back to it, and I'm going to pick a start point, and I'm going to go to width again, and then it asks me, what is your starting width? And right now it's at 0.5 because that's just what I put in, but I'm going to type 0 for my starting width and press enter. Then it says, specify your ending width, and I'm going to type 0.125, so 1/8 of an inch, and press enter. And then it says specify the next point. So I'm going to turn ortho on, and I'm going to move up here, and I'm going to move straight down in this direction right there and type 0.25 and press enter, and then press escape. So look at that. That looks like an arrowhead, but actually what it is a polyline that has a starting width of 0, so it's very narrow. It has an ending width of 0.125, and it has a length of 0.25. So this is 1/4 of an inch long, and it's 1/8 of an inch wide. Okay, so I'm going to go through that really quickly again. You pick on Polyline, and AutoCAD says specify the start point. So just pick a point. Then what you want to do is go to width. Pick on width, or type W and press enter. It says specify a starting width. We're going to type 0. That's going to give us the point, and press enter. Then it says specify the ending width of that line. I'm going to type 0.125 and press enter. And now it wants to know how long is that line. So I'm just going to move straight down with ortho on, and I'm going to type 0.25 and press enter. And then I'm going to press escape. And what that does is it draws me a sharp arrowhead but that's big, that I can put on the end of this. So what I would do is I would just delete this guy, and then I would come over here and I would use copy. I would pick on that polyline and enter. For my base point, I would pick right at the bottom of it, and then I would just come over here and move it right there. I would copy one there, and I would copy one at the other end right over here. Okay, and that's how you could get those big arrowheads in there. But it's also a good exercise in learning how another way to use a command like Polyline. Okay. All right, so that's how I would put the cutting plane line in and get your arrowheads on there. So that's the first assignment. This should go pretty fast, this one, and then you can just print it as a PDF and send it to me. Then we go on to the second one, and this is what that second assignment is going to look like. You'll draw your front view, and you'll draw your top view, and of course you'll just project everything straight up from all of this. And so you can see this counter sunk hole that we have here, and then we have 2 counter bored holes. And if you can get one of those drawn, you can mirror it to the opposite side over there. So what we have in the way of videos in Chapter 8 is this is called the flange bearing. There's flange bearing front view, there's a video for that, and there's a flange bearing top view for this. And then it goes into how do you add the section lines and the cutting plane line and all that sort of stuff in here. And then it also goes into how do you create your dimension style and get this guy to write all that. So if I double click on that, you can see that that's just text. And when I highlight that right there, if you look right here, you can see that that's GDT. Before I changed it to GDT, it was just Arial. So I can find Arial here. All right. So it starts out, you're just going to type a lowercase w and then a diameter. You can get your diameter from your symbols and all that. Then after you get it written, you double click on it and you highlight the W, just the W, and you go up here and you type G, and that'll throw you down into your G's, and then you can scroll down until you find GDT, Geometric Dimensioning and Tolerancing. Pick that, and then close your text editor, and it takes that W and it changes it to a countersink symbol. Same thing happens over here. You're going to put a lowercase v in right here and then change it to GD&T. Then there's also, you're going to put a lowercase x in right here and change it to GD&T, and this is the depth symbol. So that's the depth of the counterbore. So when you see the depth, like right here, that's what that is. Okay. Now, for you guys who are quick at drawing stuff and you're adventurous, here's an extra point opportunity for you, and that is to draw a isometric section view and add that. You don't have to. This is just for folks who finish fast and who want to kind of challenge themselves. So in Blackboard, I've put a help sheet, and the help sheet shows you to start by drawing the thing full size, just as a regular isometric, just like what you've been doing. So of course you're going to change your isometric snap and grid, this guy right down here, and get that set correctly, and do your F5 again. And this is going to be an iso ellipse, and then you'll copy it straight down and so on. So you'll create your isometric view. Then you'll go from the center of that ellipse and you'll figure out where the cutting plane would be that runs right through the center of this guy. And then you're going to trim everything that's on the front of your cutting plane, and you're going to add a hatch pattern to it. And then you're going to get to this step right here, and the thing is that it's going to be too big. So let me show you how big your view is going to be. Your view, if I use the scale command, is going to be this big right there. And when you move that over here, it's going to be too big to fit on this sheet with your views. So what you need to do is scale this 0.5. So if I go back to model space, so once you get it drawn large like this, you want to use your scale command. So this is scale, and it says select objects. So you would window the whole thing and press enter. Then it says select a base point. You could pick at that corner right there if you want to. And when it asks you for the scale, type 0.5 and press enter. And that will scale this view to half scale, and then you can move it in here. And even at that, you're probably going to want to move your front and top view to the left a little bit, and then add this in there if you're going to add that. But as I said, this is optional, and this is for extra credit. But it's a good test of your ability. So there is a video for this in Blackboard. All right, so I'm going to click on Blackboard and move this over here. So hopefully you're seeing Blackboard right now. And so what you want to do is log in and click on Chapter 8. And there is a video on the theory of section views, which is pretty much kind of what I talked about today. And then here are your assignment folders, and here's what it tells you have to draw, 8.1 and 8.2. When you pick on this assignment folder right here, though, you're going to open the Imperial prototype and rename it as flange bearing. Here's the video for the front view and the top view and the section view. Here's that help sheet PDF. So I'm going to click on that and show you what it looks like. That sheet I showed you, that will help you figure out how to draw these counterbore and countersunk holes. All right. And so that's that PDF right there. And then there's a video on adding dimensions to the flange bearing. And so here's the video on adding dimensions. And there's even a video on adding the counterbore and countersink symbols to those notes. So we've tried to give you as much help as we can in Blackboard if you need it. Okay. So I don't want to hear any complaining. You got everything you need. All right. Just kidding. If you want to file a complaint, go ahead. So that's the assignment. So I'm going